focus and directrix. I'm going to do a quick explanation of what they are, and then I'm going to do just a couple problems to kind of explain how to solve them mathematically. So what we have here is a parabola. And so if I focus on the parabola, a parabola has a vertex. And so the vertex is always a coordinate, right? It's like an xy value. We're going to go beyond that today. Today we're going to talk about something called focus and a directrix. Focus is a coordinate. It's also an xy value. But the directrix, this line here on the bottom, it's going to have a value of y equals because it's a line. So the focus is a fixed point, and then the directrix is a line. So the focus is always inside the parabola. The directrix is always on the opposite side of the vertex, and they're the same distance apart. So from the focus I have here to the vertex, they're 1 unit apart. Notice the directrix is 1 unit on the opposite side of the vertex. We call that spacing, by the way, the p-value. So the p-value is the distance between the vertex and the focus, and that distance is the same between the focus and the directrix as well. So what's special about a focus and a directrix? If you were to take a perpendicular line from the directrix and you hit the parabola, the focus is going to be the same distance as the parabola as the directrix is. So like if I were to pick a point on the left side and I went straight up at a right angle, this location that I'm circling should be the same distance to the focus. So those are the same distance. That's what the directrix and the focus is. And so what we're going to discuss is we're going to discuss how do you find the coordinates of the focus, how do you find the p-value, and how do you find the equation of the line of the directrix. Now I'm not going to go over the vocabulary here. You can pause the video if you want to, but these are on Canvas and we did these in class. But if you want to, you can copy this down if you need to. What I'm going to do is I'm going to solve problems related to this. And this can get technical and it can get tricky. There's 2 ways of solving it. I'm going to show you how to solve this by either using like algebra and some formulas, or I'm going to show you how to just graph it on a graph, and that make more sense too. But one thing we need to discuss is a parabola can open up and it can open down. If the parabola opens up, your focus is going to be above the vertex and your directrix will be below the vertex. If your parabola is opening down, your focus will be below the vertex and your directrix will be above it. So depending on what's going on here, so like if I have my picture here again, you can rotate everything around and notice how the focus and the directrix flipped. So be careful here. Whenever this happens, this affects the p-value. Your p-value will be positive, like a +1 or a +2. It'll be a positive value whenever we have our parabola opening up. The p-value is basically the distance and the y values from the vertex to the focus. So if your focus is above the vertex, we're going up, that's positive. If our focus is underneath the parabola because it's flipped and it opens down, then your p-value can be negative. Because we're thinking about relative to the vertex and the focus, I'm going down, and down on a graph is negative. Now the vertex can be used by finding this equation hk. We discussed hk when we did y equals a times x minus h squared plus k. So this is vertex form. We discussed the other day that your h and your k are the coordinates for your vertex. So we're going to use that knowledge to help us out. We've also discussed how your axis of symmetry, so that is the vertical line that is going straight through the vertex. That is the equation x equals h, and again, that is just the h value of your vertex. This is old knowledge that we've learned in the last few days. The focus and the directrix are what I'm going to focus on today. So to find the focus, you can take your h value as your x coordinate, and then you take your k value and you can add your p value to it, and that'll get you the focus of that parabola. The directrix is just your y value. It's a line. So I'm going to ignore the h here. It's your k value minus your p value because it's on the opposite side of your vertex. So we're going to use this. I'm going to explain this in detail, and hopefully it'll make more sense to you. One thing that I did not mention is the vertex and the focus are always on the axis of symmetry. They are always vertical of each other. So vertex and focus are always above and below each other. That's important. So let's look at these first few examples and kind of knock out some of these problems. So it says, finding parts of a parabola. It says, given that a parabola opens, that should say up. It says the vertex is at 3, 5, and we have a p-value of 1. Find the following. So we need to find the focus, the directrix, and the axis of symmetry. Keep in mind, your focus, we can use the equation h comma k plus p. The directrix is y equals k minus p. Axis of symmetry is x equals h. And so we were actually given our h and our k when we were given the problem, and we have a p-value of 1. So we can actually stick all of these into into these formulas and equations to solve the problem. So my focus is going to be at 3, 5 plus 1, because that's my k and my p-value. So that ends up being at 3, 6. So that's my focus. My directrix is y equals k, which is 5, minus 1, because again our p-value is 1, so 5 minus 1 is 4. So that's y equals 4. And then my axis of symmetry is just the h value. That's x equals 3. And I will graph this on a coordinate plane to make more sense of this. So if I'm going a little fast, you just might need to rewind, whatnot. I've got limited amount of time before I got to stop this video because somebody else needs my room in about 7 minutes. So I'm going to kind of get started on this one here. So I will do the same thing, but I'll use just a graph. So I'm going to plot. Let me see here. I'm going to zoom out a little bit. So I'm going to solve this just using a graph instead. So sorry, I'm trying to get this lined up with the camera. So we have a vertex at 3, 5. So over 3, up 5. So that's my vertex at 3, 5. Notice they gave me a p-value of 1. That means my focus is going to be up 1 unit to get to my focus. So it's going to be at 3, 6. That's what we're doing when we take this k plus p. We're just adding that p-value to the y value, and it gets me a 6. Now your directrix is going to be in the opposite side of the vertex, but the same distance apart. So instead of going up 1, we're down 1. This line is hitting the y-axis at 4, and that is your directrix. So I'm going to put dir here. And then I wish I had another marker, but I don't. Your axis of symmetry is always going to be bisecting the vertex here, basically, the parabola, and that is going to hit where x equals 3. And I don't have another marker, but basically we could eyeball our parabola going up here, and so just kind of have a picture of what's happening. And so you can graphically do this, or you can use algebra to solve these problems. So I'm going to look at, I'm going to skip number 2. I'm going to jump to number 3. So I think 1 and 2 are very similar. So I'm going to look at number 3, and we're going to solve this one. It says, given that the parabola has a focus at 0, 1, and a directrix at y equals 3, find the following. And so we need the vertex, which is my h comma k. The p-value, we're going to have to figure that out, probably using a graph. Axis of symmetry is x equals h. Now, these two guys here, this is not my h and my k. And this right here is, we don't know what these are. I'm going to have to go to a graph to solve this one because it'll just make this problem a lot easier to understand. We could do algebra, but the math is just way more complicated, and I don't want to worry about that. So I'm going to focus on locating where the focus is. It's at 0, 1, so that is, zoom out a little bit more. So 0, 1 is up 1 from the origin. That's my focus. Let me kind of focus the lens here. I'm using focus a lot right now. and my directrix is going to be at y equals 3. So this is my directrix. So I need to find the vertex. Well, the vertex is smack dab in the middle of those two. So that is my vertex, and that is at 0, 2. And then my p-value is going to be a little sneaky here. My p-value is the distance from the vertex down to the focus. Notice I'm going down, so that's a -1. So my p-value is a -1 because my focus is below my vertex. So to move from my vertex to my focus, I'm going down 1. That's a -1. And then we know the axis of symmetry. It's just my h value, and that is 0. So this would be x equals 0. So that's my p-value. We have my vertex. So hopefully that makes a little sense. I'm going to do one more problem real quick. I'm going to flip the page, and I'm going to discuss real quickly here one more concept. And that is if you need to come up with a formula for this parabola using the p-value. So we have vertex form, which I mentioned on the previous few problems. You can use the a value to find the p-value. So basically, if you set a equal to 1 over 4p, that will let you find the p-value, or that will let you find the a value depending on what you're given. So I only have time to do one more problem. I'm going to focus on this third one here. So I'm going to note that I have my h and my k. My focus is my h comma k plus p. Directrix is y equals k minus p. Axis of symmetry is x equals h. And then I have this equation from above that I'm going to use. I'll write it down right here. We have y equals 1 over 4p times x minus h squared plus k. So I'm going to go a little quick here. I'm sorry, but I'm going to get kicked out of here in a few minutes because somebody else needs my room. So I'm giving you the vertex, and I'm giving you the focus. And I need to use that to find all this information. Now, for one, I know my h value, and that's going to give me my axis of symmetry. It's x equals 1, because I'm getting that from my vertex. Now, I also know that I have y equals 1 over 4p. I don't know what my p is, but I do know my x value, again, is 1, and my k value is 4. I'm just inputting 1 and 4 for this h and the k. So I need my p-value, and that will help me find my directrix. I'm going to go back to my whiteboard, because my whiteboard is going to give me what I need. So I'm going to write down the vertex and the focus, and that will give me my p-value and my directrix, and that will help me solve the equation. So I'm going to put 1, 4 as my vertex, and 1, 3 was my focus. So 1, 4 and 1, 3. So I know my directrix is on the opposite side of my vertex, but the same distance away. So that is hitting at y equals 5. So that is my directrix. So y equals 5. So I don't need that equation to solve that part. Now my p-value is the distance from the vertex to the focus. I'm going down 1, so my p-value has to be a -1. So I can input a -1 in for my p-value, and it's confusing, so let me go up here. So we have a equals 1 over 4 times -1, that's my p-value, and if you multiply this out, you get an a value of 1 over -4, because this -1 times 4 is -4. So I end up with a value of y equals -1 over 4 times x minus 1 squared plus 4. That is the answer. Oops. That is the answer to number 3. And I wish I had more time to go over more of this, but I'm being kicked out of my room right now. So if you have any questions, please let me know. Other than that, I hope this helps you out. Have a good day. Bye-bye.